All right, guys, welcome to Algebra 2 sections 1.1.3. So we're going to take a look at, first of all, something that we kind of talked about back on the very first day. This is from problem 2 when we had those 4 different function machines. We had to find the right order to put them in order to get the input giving us the final output that we were looking for. So they're going to kind of go over a few different strategies which we kind of talked about earlier. So they're saying, hey, if I use G as my first one here, I get a negative 16 out of it. And that tells us, hey, we can't plug that into rad of x because negative 16, if you take its radical, you get a non-real number. So you can't actually use that anymore. So that's kind of a limitation there, which we kind of found too, right? So there's other values which we can't use in there as well, right? So we could plug in, say, -3, and -3 would not work in that rad of x. We could try -20, and it wouldn't work in rad of x. Basically, the things which don't work are going to be anything that is a negative value. So that's what's called a domain restriction on that function, right? It can't have anything that is negative. So the domain of this f function, right, would be any value that is 0 or larger. So positive numbers and 0. Okay, so that's going to be the domain of that, meaning that the only thing which can be inputs for it are positives and 0. So no negatives can be its input. Now we kind of figured that out and said that we just maybe didn't use the term domain. So we're trying to kind of relate this word we've used a bit in the past to what we just saw earlier. And then Sonia here says that if our final output has to be 11, which is a positive number, the function g will always make an output negative, so it can't come last in our order, right? So her basic claim here is that the g function, which is right here, right, will always make things negative. And we kind of said that too, right? We said, well, if I take whatever's in here and then square it, it'll always make it positive because squaring things always makes them positive. And that positive value then being made negative will make it always negative. And since we need our final output to be positive 11, G couldn't possibly be our final step there. Now we didn't maybe say that one specifically, but we can see, hey, that makes sense. And we did say, hey, G will make things negative. So that's another thing we're kind of looking at there. So now that is an example here in part D of a range being determined for us, right? So our range on G could never give us an output or a Y value that was positive, right? It had to be 0 or a negative value. So the range there would be anything that is 0 or negative, right? So we're just trying to relate those domain and range terms to the stuff which we kind of did and kind of used to kind of help us solve those problems earlier. All right, so next 2 problems here. They're going to ask you to use a graphing calculator here. I'm actually going to use Decimal, so I need to open that up real quick though, so that it'll pop up for us. So go ahead and pause this, and on Desmos, try and answer those particular questions. And then you can resume, and I will kind of pick up and answer those questions here. All right, so let me just go to this. There we go, there's my decimals. All right, so we're going to be looking at, the first one here is x plus 1, x minus 9. Let's go to x plus 1 times x minus 9. Okay, so then I get this. So ideally, we're doing this on a graphing calculator, but we can still see the same effects here. So they're saying, hey, what's wrong with the window here, right? Because I'm only seeing really part of the graph. I'm seeing like a little bit here over here, and then this part here. I'm definitely not seeing the full graph. Now you should kind of know, hey, this should give me a parabola when I graph it. And the problem is with our window or our kind of zoom in a different word. So if I actually zoom out, if I mouse wheel out or use the plus and minus stuff here, you can actually zoom out until you can see the actual full shape of that graph. So they're really just trying to get you used to actually using those zoom features, because quite often we're going to be seeing very large, very complex graphs. And when you first graph it, you're going to see like this is like, oh, it's just a linear function. But no, this is not a linear function. If I zoom out, you can see, hey, it's actually a parabola. It's a quadratic function for me. Right, so those are kind of some of the important stuff for us to kind of notice there. What settings Alg2 see that? Those are answers that are going to be more inclined for an actual calculator, which I would do if we were in person. But that's also going to be our little substitute that we're going to use for the time being. Same thing with these. So then setting-wise, what I actually do here is set my window to like -30 to 40 is what my current window is as far as range goes, and my current domain is like -30 to like 30. So you're going to kind of set your view window depending on what the domain and or what the range is for your particular graph. Again, this matters a little bit more if you're using a graphing calculator versus just being able to zoom in and out with this. And then number 28, right, we're going to do the same thing, but we're going to graph x minus 12 squared plus 11. All right, so there we go. So we're going to get this one here, and now the standard window is going to be 10 by 10, and we're not going to really see it in that window, right? So hey, we graphed it. It doesn't graph. That's not the answer here, right? So we're going to have to say, well, what do I know about this particular graph? Well, I know that this 12 is going to move it over 12. This 11 is going to move it up 11. So hey, here's actually where it's at. So I can change my zoom to kind of find where it is, and then I can have a much more useful time there. So that's really the main crux of what we're trying to do here, is get you used to changing windows in order to find the parts of the graph you care about, right? You should see this and say, hey, this has a little second power in there. This should be a quadratic or a parabola. Let's try and find the parabola. If you know you're looking for a parabola, don't stop looking and changing your viewing window until you see the vertex of that parabola. That's one of the most important parts of the graph there. And then what are the domain and the range of this particular function, right? So on this one here, the domain, well, this goes left and right forever. So its domain is going to be all real numbers, or from -infinity all the way up to +infinity for us. And then range-wise, the lowest point that this ever gets to is 11. So it's 11 and up. It's going to be my actual range. All right. So let's take a look at the next one. Change to this. Sorry, a lot of buttons to run this. Okay, so number 29. You're going to reverse your thinking and create a graph with the given domain and range. So what I want you guys to do is go ahead and pause and answer A and B on your own paper, and then go ahead and resume once you've done that, and you can kind of check what you've done with what I'm going to do here. All right, so we're going to be sketching these now. If I change over to my document camera, right, I'm first of all going to draw out some X and Y axes here. It doesn't have to be perfect, but I want something to kind of be referencing here. That's a little bit light, sorry, make it darker. The purple on the red is not easier, it's not so easy to see. But okay, so I need it to have a domain of everything between -3 and +10. So if I change my scale here to being like 2, so this is 2, 4, 6, 8, 10, -2, -4, -6, -8, and then we're going up 2, 4, 4, 6 down, -2, -4, -6, right? And then I want my range to be everything between -4 and +6. So And this is not a necessary part of the graph, but I do this to kind of help me kind of see what's going on here. If my domain is only between -3 and 10, I will never go past this little, that's not working well. Let's try a different color. This little wall here at x is -3. Right? Again, that's not part of my graph. I'm just trying to see, hey, there's where my -3 is, and then it goes all the way up to +10. So I know its domain is everything between this wall and this wall. Okay, so it has to go between those. And then its range is this kind of same thing, but vertically. My lowest point is going to be -4, so I never get lower than that, so I'll put a little wall there. And I never get higher than 6, so I put a little wall there, right? So at this point, you can draw any kind of function that you want, so long as one, it's a function, and two, it meets these requirements. So if I just drew a line, like let's say here, do a little curve like that, right? Does that meet the domain requirements? Well, yeah, it goes all the way from -3 to +10. Great. But does it meet the range requirements? Well, I'm within the range, but it doesn't include everything up to there and everything down to there. So I have to actually go all the way up to this and all the way down here. So what I would need to do is something that maybe looks, maybe it goes up and it touches, and then it comes back down, and then it bounces, and then stops there, right? So I'm touching there, touching there, touching there. Again, it can look however you want. What's important is that it is continuous. It at some point gets to this -3 part, gets up to this +6, down to this -4, and over to this +10. And it can do that in any order, but it also has to be a function still. So do your kind of vertical line test. Does it pass that vertical line test? Yeah, so we're good. Okay. And then part B says that our domain is now 2, 4, 5, and 8. Sorry, our range is 2, 4, 5, and 8. Our domain is all real numbers. So let's take a look at that, because this is one that's a little bit more tricky. It requires a bit more thought on it. So our range is not everything from here to here. It is some fixed number of actual values, 2, 4, 5, and 8. So while here, my range is -4, it's -3.99999, it's -3.2, it's -3, it's every possible number between here and here. But over here, it can only be 2, 4, 5, and 8. So let's go ahead and label those. 2, 4, 6, 8. I probably didn't need the bottom part of my graph here, but oh well. Okay, so if I were to say, well, it's 2, 4, 5, and 8, well, I could put like a dot here at 2, a dot here at 4, a dot here at 5, and a dot here at 8, right? Those series of just 4 points meet my range requirements. So that's good. But those don't meet my domain requirements, right? My domain is that, hey, this goes left and right forever. So how can I do that but not hitting any other y values? Well, I need to do horizontal lines. What if I did a horizontal line all the way here, and that goes forever, so I have to put a little arrow on it. Then maybe I want this one to kind of just be here to here. I'll do this one here to here. And I'll do this one here to here. So they might actually here and then all the way over, because it has to keep on going to the right. So you might remember these as being kind of step functions. It's not a true step function, but same kind of idea there of just a series of these horizontal lines. So now do I meet the requirements? My domain is everything, right? It goes left forever, right forever, and even hits every value as I'm kind of changing here. And then my range is only 2, 4, 5, or 8. It's never any other values than those, right? So we're just trying to kind of get you to look at these graphs and think about domain and range in a little bit more of a reverse form, whereas I give you the domain range and you give me the graph. So again, your graphs do not need to look exactly like this. As long as you're still meeting the same requirements, you're great. If you're not quite sure, email me or contact me or ask me when you see me next, and I'll try and double check and make sure that, yeah, those are meeting the requirements for us. All right. So next one we're going to be taking a look at. We're going to use our graphing calculators to try and solve this system. Again, you can just use Desmos, right? So we're going to graph both of those in Desmos and then use that to answer to solve the system. What x value and what y value makes it true. A lot of these questions here for B, C, D are kind of more graphing calculator specific versus Desmos specific. So all I'm really going to say to do is solve that on Desmos and then just kind of think through the process of what did you do to solve that on Desmos. Try that out, pause it, and then resume once you've done, and I will go through how I'm doing that. Okay, so let's hop back over to Desmos. Let me just delete these things out. And what I'm going to be graphing is 5x minus y equals 35, and 3x plus y equals negative 3. Okay, so if I were on my standard window, which would look something more like this, right, 10 by 10 idea, right, I'm not going to see the answer, right? But I can hopefully kind of see, hey, well, this purple line's going kind of down here, the green line's kind of going down here. What I really care about is where those intersect. So I want to kind of zoom out or scroll down, say, hey, here's those points where those intersect. Now on Desmos, it's a lot easier to find those intersection points. You're not going to see that grayed out right now on my screen, but if you have your cursor on either one of those, then it'll put the dot on those intersections. That's just to keep, if you have like 20 different graphs, it'll only look at the intersections for the one you are currently looking at or have your cursor on. So for negative 15 is the point of intersection. What that means in the context here is that 4 is the x value and negative 15 is the corresponding y value that make this system true, right? So that would be how I could solve that system graphically. And once you get really kind of fluent with solving things by graphing, it's super, super fast and super, super easy, right? The issue is if you don't have access to a graphing utility, like it can be very, very difficult to solve these by hand. This one's not too bad because they're both linear, but when you get very, very complex graphs, graphing utilities save you tons of time as far as trying to solve those things out. All right, so let's hop back over here. And then with that, we're just going to take a look at a few bits of notes here. We've talked about domain range a little bit in the past. We talked about that quite a bit today. Go ahead and read through this. If there's things you feel like you don't know or aren't very kind of common knowledge to you, then go ahead and write those down. But most of this is stuff you should kind of already know. I do want to talk about the symbols here. We're going to be kind of going away from this notation, where this is likely the notation you're more used to seeing in the past of, hey, it's everything between negative 2 and 7. That's kind of how we would write that. If it's two separate regions, we can say, hey, it's either bigger than 4 or it's between 4 and positive infinity. Those both say the exact same thing. But here we just kind of added on that little is less than in infinity. That's trying to get you trained to what we're going to be doing in the future with what's called interval notation. You may also see stuff like, hey, it's everything but negative 3. Okay, that's a much easier way than like saying, hey, it's everything less than negative 3 and everything bigger than negative 3. Or you can just say, hey, it's everything but negative 3, which is kind of what that notation means. And then lastly, all real numbers, you could just write that, or you could say, hey, it's everything between negative infinity and positive infinity. Again, they mean the exact same thing. All right, so with that, our closure, let's kind of think about how you used the graph to solve the system. How could you use that to solve other systems? It should be a fairly similar process. Just kind of think about that with yourself. And then to round off here, here is our homework for 1-1-3. So I will talk to you guys next time.